Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the hard problem of the LeetCode. Its index is 850 and its name is like rectangle area second. Okay, so before moving on to discuss this problem is I just want to summarize the topics that is being related to this one is geometry. You need to have the good knowledge of geometry, like the figures, how the overlapping is being done, how we are going to handle the overlapping. Like in this problem we have some overlapping of figures and we need to calculate the area, right? So and for the case of overlapping of figures, you need to consider that area exactly one time. Okay, how we are going to handle all that case and what would be the best way to code, I will tell all of that. For now, let's understand this problem. Okay, so we'll be given a list of axis aligned rectangles. Okay, so each rectangle will be given the four datas, like the bottom left corner you can see x1 y1, and top right corner x2 y2, right, are the coordinates of bottom left corner and the coordinates of top right corner of the ith rectangle. Okay, so we'll be given n rectangles. Find the total area covered by all rectangles in the plane. That is, if you draw out the rectangles, then there would be some, they will be occupying some area, and we have to report the all the area that is being covered. Now it is obvious that two or more rectangles are going to occupy the same area in the 2D plane. Then we need to account for that area exactly one time. We are not going to count two or more times. If you are going to count two or more times, this problem should not be a hard problem, right? Okay, since the answer may be too large, return it modulo this prime number. Okay, so I'm going to discuss all the examples. Okay, so you need not to be worried about. So for now, let's look over the constraints, how this is going to help us. Okay, you can see the rectangle's length, that is the input rectangle, that is the total number of rectangles is 200. Okay, so we can have a O of n squared solution, we can have a O of n squared log of n solution, right? Because it is also going to satisfy within the given time constraints. We can also have O of n cube solution, like it should be around 8 into 10 raised to the power 6, and this is within the limited number of iterations, and this is good. Okay, so for now in this in this video I'm going to explain it out the O of n cube solution in the best possible way. I know the complexity is like huge, we can have O of n squared solution also, but to understand this problem, to have a deeper feeling about this problem, what is actually being happening over here, I will recommend to understand the O of n cube solution, then we can optimize that. Okay, and there is another solution that I'm also going to discuss. It should be like O of n cube, logarithmic of n and logarithmic of n. That is not good, but it has a good complexity. I don't know why. We will discuss it later on. For now, let's try to understand this problem with the help of examples and diagrams, and then we'll together find out the best solution for this problem. So let's move further. Okay, so let's try to figure out the analyze the example one. Okay, so we'd be given the first rectangle as 0022. Okay, so let's say it is like at 00, that is at this position, and it is like 2 and 2, that is 1 2 1 2, it is at this position. So the very first rectangle is about this one. Okay, I'm going to do like that. Okay, so this is the area that is being covered, and this like the answer is going to be like at least this one also. Okay, so there may be some overlappings. Let's discuss this. About 1023 is another, like 10, so it should be like 1. Okay, so let me use another color. It should be like x1 and it is y0, so it is over here, and it's like 2 3 2 1 2 and 3. Yeah, it is this one. So it means that the chord the rectangle is going to hold this one area. Okay, now you can see that this area is being overlapped. Okay, so we are not going to account for this area because we have already found out that area. Okay, so we are always going to consider some unique areas for a given rectangle. It is like only this one. Okay, and let's look over the another rectangle 1031. It's of 1 and 0, and it's of 3 and 1, 1 2 3 and 1. Okay, so this one and this one, it means that all the positions over there. Now you can see that there is also some overlapping, so we need to consider only the unique areas, so we are going to consider only this one. Okay, so these are like the shaded part is like our answer, and we need to report that answer. So what is the answer? You can see 1, 2, 3, 4, 5, 6. I think 6 should be the answer for this one. Yes, 6 is the answer. Okay, so it means that you need to account for the like distinct blocks that is being not repeated. Like if you have been already calculated that area, we are not going to do that. Okay, now the thing is like how we are going to manage that in like in a limited time. We have to write down the code, right? So we need to have an efficient way to find out that area and check that these are going to be like accounted for the very first time. If it is a repetition, we are not going to do that. Okay. Now the problem arises when you can see the rectangles of I is like 10 raised to the power 9. Now, if it is around 10 raised to the power 5, you are going to maintain a linear vector, a 2D vector or something like that, I don't know. And you are going to do that easily. But here it is like 10 raised to the power 9, and this creates the problem. How this creates the problem? How we are going to find it out that there is an overlapping over here? Okay, so no need to worry about. Let's try to understand this in a different. Okay, so consider this example like there is some overlapping you can see over here. Then what I am going to do is like the best way to solve this problem is like map all those x coordinates which are distinct, right? I'm talking about the distinct x coordinates in some vector, linear vector, like in a sorted non-decreasing format. Okay, you can see 0, 70, 100, 220, 270 and 320. These are the distinct x coordinates. You can see 0, 70, 100, 220, 270 and 320 are the distinct x coordinates. Similarly, we are going to map all the distinct y coordinates over here. These are the y and these are the x. Okay, now these are the distinct ones. Now the thing is like when we are having some rectangle, we need to include that area which have not occurred, right? So mapping these x unique x coordinates like this one and unique y coordinates like this one is going to help us in the best possible way. Also note that we cannot maintain a linear size vector of the maximum possible height or width because rectangle of ij can vary up to 10 raised to the power 9, and if you are going to make a linear vector of like for the x coordinate and y coordinate size to 10 raised to the power 9, this is not possible, right? Come on. Okay, so we have to do something interesting, and the interesting part is like we are going to have a unique x coordinate in some linear vector, unique y coordinates in some linear vector. Now how we are going to calculate the areas? Okay, now consider that we are going to have a, like we are talking about the very first rectangle, this is being introduced right now. Okay, so you can see that it is going to vary from 0 comma 0 to 100 comma 100, right? Okay, so it is going to vary from like x is varying from 0 to like 0 up to 100, and y is also varying from 0 to 100. Okay, now we need to include all those areas which are for this rectangle. Okay, how we are going to do that? Okay, the very best way is to like consider every adjacent part 0 to 70, and consider like not talking about, consider every adjacent ones. Like for 0 to 70 there are 0 to 10 adjacent, 10 to 30 adjacent, and 30 to 70 adjacent, 70 to 100 adjacent. Like for every 0 to 70 X segment, we are having different Y segments as 0 to 10, like this is for 10 one. Like for every 0 to 70, we would having, sorry, 0 to 70 only. We would having Y from 0 to 10, and like from 10 to 30 also, like from this to this, we would have be having like of this one. And similarly we're having from 30 to 70. So where is 70? Yeah, 70 is up to this one. We would be having this one, and it's 70 to 100. Where is 70? And it is 100. We would be having this one. You can see that we are accounting for only the distinct ones. Still this rectangle contains much more area which is not covered. We are going to introduce it later on. You can see I'm talking about only 0 to 70 part. What about 70 to 100? We would be discussing later on. Okay, so for 0 to 70, we would be dividing each segments from 0 to 100 where the y coordinate lies into some different parts. You can see from 0 to 10, from 10 to 30, 30 to 70, and from 70 to 100. Okay. Now for every adjacent coordinates difference in the x part, we are going to find out the every coordinate difference in the y part, and we are having the length also, we are having the width. So our answer would be incremented by length into width. for the current rectangle. Okay, now like if let me just do some brute force, like if we are only dealing with 0 to 70, what is the difference in x? Okay, difference is x is 70 minus 0, it would be 70 only. Difference in y would be like 0 to 10. In this case our answer would be incremented by 17 to 10. And again like again in the next case 17 to 10, difference of 10 and 30 is 20. And again the next case 30 and 70, so 17 to 40. And then again 1700, so it would be incremented by 17 to 30. These all are the answers that should be included when x is going to hold this range. Okay, now the x, like the adjacent ones in the x, can vary from more different cases. Like we have dealt with 0 to 70, we are going to deal with 70 to 100, like for this part. Okay, so x, like y coordinates, is also going to vary from 0 to 10, 10 to 30, and like 30 to 70 also, and similarly from 70 to 100 also, and so on. Okay, now this is not the like this was the very much easiest part. Now when we try to introduce the new rectangle like of this one, okay, so now this creates some confusion, like there's some overlapping also. Let's try to understand that how we are going to handle that overlapping. Now consider the case like this is being involved, like this rectangle from this one to this one, and from like this one to this one. Now you can see for this rectangle it starts at 70 x coordinate and ends at 270, like this part. We need to account for every possible areas, okay? And let me check it out if there is an overlapping also. And its y coordinate starts from 30 and it goes up to 130, like of this one. Okay, now when you try to explore every possible adjacent x coordinate, like from 70 to 100, you can see, and for 70 to 100 we are exploring like 30 to 70 y, and 70 to 100 this one, and 100 to 130. Now when we are at 30 to 70, you can see that for every, like for 70 to 100, and this is for x, and for this is for y. Like if we find out the 70 to 100 case, where is that 70? Yes, and where is that 100, like for this part? And what about okay, so what about this 30 to 70, and where is the 30y, and this is what 30y, and where is that 70? Yeah, this is the 70 part. Okay, now the thing is, like when we are just having this as our answer for this current case, you can see that this has already been calculated. Okay, why this has already been calculated? Okay, the quite noticeable thing over here is like when we are calculating 0 to 100, and like for this very first rectangle 0 to 100, and y is also varying from 0 to 100. Okay, in that case for every adjacent x, you can see that we are going to visit 70 to 100 in this one also, and we are also visiting 30 to 70 in this one also. Okay, so in that case we have already find out that area. Okay, but now in this case also we are trying to visit from 70 to 270 in the difference of x, and in the case for y we are visiting 30 to 130 also. In this case also for adjacent difference of 70 to 100, like for the 70 to 100 segment, in case of x we are again visiting 30 to 70, and this is like when we try to include this area, this will give us a like, wrong answer, because this is being calculated twice. We need to check it out that this should be visited exactly one time. Okay, so if this is already visited, this state has already been occurred, we are not going to find out that area. Otherwise, find out that this area and include it your answer. Like in the case of 70 to 100, I'm talking about. Consider the case for 22, 20 to 270. Okay, in this segment, we need to include the answers for every y, every adjacent consecutive y from 30 to 70, 70 to 100. Like it is the case of 20 to 20. Where is that 220? Yeah, this is, and it's for 270, and y is going to vary from this one to this one. Okay, yeah, I'm right. Okay, so in for that case we are going to include this area every time. Like you can see this is not calculated yet. Okay, and if this is being calculated, we are going to mark these cells as visited. How it is going to be done, I will explain in the coding part. and mark this cell as visited, and when we are going to encounter these cells again, we are going to discard that cell because we have already calculated that area. Okay, now the coding part is like really very much simple. If you consider like if you have understand all these concepts, how the overlapping is being occurred and how we are going to find out the area. We are going to map out all the distinct x coordinate in the linear vector, and similarly y coordinates, and we are going to account for every adjacent difference of x coordinates and y coordinates for every rectangle that we are going to get. Okay, so let's move further to the coding part to understand this. Okay, so you can see that I have submitted many times to improve the complexity. Okay, so let me first talk about this latest one. Okay, so what I've done is like this is LL for as long, and this is the modulus prime number. And like first I've mapped all the unique x coordinates and y coordinates. You can see that for every rectangle I've iterated for that and take out their x, take out their y, and include into a set. Okay, now this part is like assigning the indexes, like we are going to map all those unique x into some vector. Like here you can see vector int x value, vector int y value. You can see that this is like x dot begin up to x, like all those element unique x which are present in this set, and similarly the unique y, we are going to store it in a vector. Like when we try to fetch some element and we need to know its index also, right, efficiently. That's why I'm using an unordered map to map every unique x as well as every unique y, like giving some unique index to it. Okay, you can see over there. Okay, so what we are going to do is like we're also going to maintain a visited vector of like unique x size and unique y size. Okay, and this is for checking it out whether we have reached this state already or not. Okay, iterate for every rectangle, pick out the corresponding x coordinate. If we have some like we are getting some unique value, right, and we are going to find out what is the coordinate of that unique x in our vector x val. You can see start of x, okay, is going to give us the starting coordinate of this current unique value, and it is going to go up to the next starting coordinate. Like for the current rectangle, if you're not understanding it clearly, like suppose we have from 0 comma 0 to 100 comma 100, what is the starting coordinate of this one? It is 0, and the ending coordinate it is up to 100. Okay, so it will give us the value coordinate, like the index, starting index of this 0 and the starting index of this 100. Okay, for the current rectangle you can see v2 will be given as this position. Okay, and it will give us the coordinate. We are going to iterate for every adjacent ones. You can see start of x is starting with the current index of this unique value, and it goes up to of v2, like start of x less than the index of v2, and it goes on. And similarly for the case of y, you can see coordinate of y, it will give us the index. Note that coord underscore x as well as coord underscore y will give us the index of that value, which is that unique value which is present in our linear vector, where it is present directly in the index. Okay, that's why I've used unordered map, okay, to map every unique value and assign its index. Now consider the case like when we are talking about some adjacent case, like let's say 0 to 70. Then what we are going to do, we are checking out if start of x and start of y is already visited. Like if current state has been visited, we have already found out the area, then we are not going to do that. Otherwise, find out the width. Width would be by x value of this start of x plus 1. That is the, like if you are at this one, we are going to have this 70 as start of x plus 1 index, 70 minus 0, you can see. And similarly this was the width, and here it would be like y value of start of y plus 1 minus this one. This is the width of the current one, and this is the height of the current one. We need to include the area, and so it be incremented by the product of this one. Note that we are going to take care of the modulus because of the overflows, like the value may exceed from that prime number. We need to take the modulus with that and mark this as visited. Okay, and finally return the answer. This will give you all test cases passed. Now the thing is like we have some more optimized solution like of this one, or let me talk about this 28 ms. I'm loving that. Okay, So what I've done is like the concept is like similar. We are going to use the lower bound technique. Okay. So you can see that we are going to map every x unique x into some coordinate of x in a linear vector. Similarly in this one, and we are going to have a visited vector also. Now for every like in the previous case, we are using the concept of index, right? We are not going to use here. We are going to use the concept of value, like it will start from the current value and it will goes up to till it is not equal to the v2, that is like the next value. Okay, in the vector you can see it is for the coordinate of x. Okay, now similarly for the y case also, and pick out the difference like the current where is the present value, like its index start of x minus the begin iterator, similarly start of y minus begin iterator. Note that here start of an x and start of y are the iterators. Okay, in the like you are taking the lower bound only, you're not fetching out the index, and it goes on till it the next value is not equal to v2, and we need to find out the width as well as height. We are going to fetch out the next element, and which is the current element is start of x. Similarly start of y and start of y also next element of start of y and start of y, and find out the product and increment your answer if this state is not visited. This will also give you all test cases passed. Okay, so if you have any doubts, do let me know in the comment section of the video. Okay. So like one thing I've also forget to like time and space complexity. So this case, like when we are mapping the indexes, it should be like time complexity like O of n cube. You can see for these three loops, worst case would be like O of n cube. Similarly, space complexity would be like O of n square. And in this case also, we are using have to have a lower bound also concept. So in this case, we are going to have a time complexity of O of n cube log of n, and similarly, and the space complexity would be like O of n square. So, okay, I'm leaving up to you to understand this in detail. If you have any doubts, do let me know in the comment section of the video. Okay, and I will recommend or I will ask the viewers to like this video, share this video, and to subscribe to YouTube channel for latest updates. Thank you for watching this video.